Hello watchers, welcome back with another video by Kurchit, and in today's video we are going to see how you can implement binary search tree in JavaScript. So this video is a part of data structure and algorithm that we are doing in JavaScript. Yeah, and one more thing, like it's gonna be more implementation sort of thing rather than explanation, but yeah, I will explain some of the concepts, like how it works and what is it, these kind of things. Okay, so without further ado, let's get started this video. So let's start by understanding what binary search tree and how it works. So binary search tree is a kind of a tree data structure, where there are like different branches. You can say there is a node, there is an edge, and basically an edge connected to different nodes. Okay, and that's how it works. But because it's a binary search tree, so there are some different and specified rules that you need to follow. Only then it will be called as a binary search tree. Okay, in binary search tree, what happens, like a child node, not child node, but yeah, a left node will be always smaller than its parent node, and the right node will be always bigger than its parent node. So this is the like a very basic and important thing to note here. A a left node will always be smaller than its parent, and the right node will be always uh, larger than its parent. Okay. With that in mind, we can start this video and like implement this in JavaScript. Although there are like a lot of different use cases as well, like where these things are getting used. Basically, tree like structure, or you can search for it on Google if you want to know so. But the focus of this video is just implementation part, so that's why I'm not gonna tell you that, because then our video will be too long. Okay, so without further ado, let's start this video. So just like here you can see we have this node, here we will have our root node, and let's try to understand like what kind of properties we can fit in our node. So there will be one node, and either it can be pointing to left, or either it can be pointing, no, not either it can be, but there will be a left pointer and the right pointer. Left pointer will be pointing to the left node, and the right pointer will be pointing to the right node. Okay, it's not like either one of these case, but yeah, the both of these node will be present there. Sorry for that mistake. Okay, and by default these left and right pointer will be null, but yeah, if we have elements and all, we can like insert there. Okay, so that's the one of the basic thing our node will consist of. Basically, that's what node consists of. And there's one inside of BST, the another class called BST, or binary search tree. We will have only one root node to say, and this root node and that node will be pointing to this the super node, or you can say the root node, like the first node in our tree. Okay, so let's see how we can build this. So in this video, what I'm taking, like I'll be explaining like how you can insert, and how you can search through the binary search tree. Okay, like whether an item exists, or whether an element exists, or node exists or not. Okay, or if it exists, then we'll return that node, or if it doesn't, then we will simply return null. Or another thing is like to push element inside this. Okay, so that's the another thing that we're going to see in this video. So if this sounds interesting to you, then watch this video till the end, and you will have a good understanding of how you can build this thing. So let's start by writing our code. Let me just go inside VS Code, and then I'll start coding. Okay, so here I am inside my basically VS Code. Let me just create a one index.js file. Okay, because you're just seeing an explanation how you can implement one. Okay, so we don't need different files here. And here first thing we will have it will be a node, of course. everything is consist of node. Not everything, but there will be node, so that's why we are keeping it in this way. So first of all, we will define our node. It will have one. So it will basically accept one value as an argument, the value of node itself, like what kind of value you want to hold inside it. So that's what it is, and we will assign this to like a this dot val equal to val. Okay, and after that there will be a left pointer. As I said, it will be default by null. By default it will be null, and there will be the right one. This one will be null as well. Okay, and now let's see how now let's jump to the bst part. I mean a class called bst. uh, Inside this bst we will accept a constructor. I think we should like plan like we should I think we should start with the empty binary history. Okay, so it will not accept any param to say, and here our root will be null, because if there is no element then it will be null. If there is an element, then we can assign the first item, or like the first, whatever the first item is, like which got inserted here, will be called our node, will be called our root. So that's how you can define this basic structure. And now we will see how you can write. We will start with basically insert method. Okay, basically pushing an item inside this. So that's how you're going to start. Okay. Okay, so we are going to take a look at our insert method. Let's see how it works. So the first thing we need to check here is like if so first of all, we will this insert method will accept a value as an argument. Okay, if there is no, so we are going to accept a value as an argument, and we will create a new node with help of that value. Just create a new node, and through our like a node instant, like a node class that we created. Okay, so we have our new node now, and what we are going to check, like if our root is empty, which simply means there is no element in our list. I mean, not in list, but in our tree. Okay, if there is no element, then what we can do is like we can simply assign this new node to our root. New node. Okay, this is as simple as that. Because if there is no element, then you can simply assign it to new node, because this is the first element uh, which is getting, this is the first element I think which is getting added. Okay, so that's why we can assign it, right? And after that, simply return new node. That's it. And now what we will do, we will cater the second scenario, which is like if there is already an element. Okay, so the thing here we need to understand here, like how you remember, like how what I said, if an item, or like if a value is greater than current node, then you will push it to the next node. I mean, I mean, you will pass it to the right node or right branch, or if it's like a lesser than the current value or current node, then you will push it to the left side. Okay, so that's how it's gonna work. That's how it's gonna work. So let's see how we can do that. Okay, so first of all, we will start with our root. Let's say let's call it let's call it current this dot root. Okay, so we have our current, and here what we are going to see, we are going to simply check while we will loop it until we reach to the leaf node. Okay, so that will be the place where we will add our new node. Okay, we cannot add like in between wherever we want. Okay, so what we are going to check, what we are going to check, like if current, if there is a current available, then as long as there is a current available, we will run it. Okay, I think that's how I'm a little bit confused. Okay, so if I'm making some mistake, just forget that. I'll like correct it later. So I'm just coding it right now. So if there is a current, what we will do, we will simply check this value itself. Okay, if value is greater than current. Okay, if that is the case, what we can do, if value is greater than current, then we will assign our current to current dot next, or sorry, right. And if that's not the case, if our value is like less than, to say, if that is the case, we will simply assign it to current dot left. Okay, so by doing this, if our value, or like if let's say we have a 10 as our root node. Okay, and we are adding a 9 here, or like let's say it has like a 9 as a left node and 12 as a right node. Okay, although it looks like a linked list right now, but please don't get into that part. Just think it as 9, think 9 as a left node and the 12 as a right node. Okay, and 10 is our root node. Now let's assume if we are adding 8 here. Okay, if we are inserting 8 as a new node, then what we will check, we will simply see the first current will be our current will be this dot root, which is like a 10, and here we will see if 8 is greater than current. 8 is greater than current. No, it's not greater than current. So what we are going to do, so it's gonna simply go inside like a else while apart, I mean else part, and here you can simply see current equal to current dot left, which means we will go to the left because it's a smaller, our 8 is smaller than the 10 actually here. So we will jump to this one, 9 1. Okay, and 9 1 as of right now, basically right now 9 is like a leaf node, our leaf node. Okay, one of our leaf node. 9 and 12 are 9 and 12, these two nodes are leaf node right now because there is no element or node after that. Okay, so we have reached at this part. Okay, and so this is the 9, and here we will simply check this again. If because like the current is still pointing to 9. If current, what this time what we're going to do, like we will check if 8 is greater than 9 or not. No, it is still not greater than 9, but there is no left. Okay, so this is the edge case that we haven't had handle here. So what we can do, we can first of all check if current dot left. Okay, only then do it in this way. Okay, and if that's not the case, then what you can do here is like if there is no element after that, then you can simply current dot left equal to new node. You can do it in this way. Okay, you can simply like assign this left node to new node and just assign current equal to none. Okay, because our task is done and we have successfully inserted our node, so that's why. Similarly, we also have to add one more check here. Yeah. Similarly, we have to do it. Similarly, we have to do this here as well. If the current dot right is available, which means if there is a right node. Okay, and then assign a current equal to current dot write. If not, if there is no node, okay, if there is no write node, which means we have reached at leaf node, we can simply do our task here. So what we are going to do, like current dot write equal to new node. Okay, that's what we'll do, and simply assign a current equal to null. Current equal to null. Okay, and I think this should work now, although I still doubt, because program usually don't usually usually don't work in first time. So I'm a little bit confused, but let's see if it works. Okay, so and after that we will simply return our new node. Okay, not like, not after this one, but uh here, return new node, and let's check if it works or not. So I'm gonna create a very basic tree, and let's instantiate with bst, and as of now it should be like a null. Okay, so npm, not npm, node index.js root equal to null. Okay, that's fine. Now let's try to insert a tree dot insert, and let's assign this a 29 here. And here we have a 29, and there's a left and there's a right. Now comes the main part. We will assign further nodes, and let's see if it is inserting it correctly or not. So we will, first of all, we'll insert something lesser than 29. Okay, so let's say um, tree dot insert 10. Okay, so this one supposed to be like this one's supposed to get inserted at like this one should be like get inserted at like left side, if I'm not wrong, because it's smaller than like 29. So if I do it in this way, okay, current equal to null. Oh, assignment to constant variable. Okay, so let me just make it let. Yeah, we got it right. So here you can see like our left is node is like a 10, which means it inserted it in right place. Okay, so now let's try to insert like something smaller than 10 as well. So this one should get inserted at like even left of like 10. So like if there is a left node called 10, and then left of this is right now null, and I think this is the place where this one should get inserted. That's what I think. So, and if I'm not wrong, like it has correctly inserted it in the right place. Okay, it has inserted it in the right place. So yeah, our this thing is working. Now let's try to insert something bigger than 39. Tree dot insert, and let's try to insert a 50 here, and I think this one should get inserted at this right place. Okay, although I'm explaining it through like console log, but as you can do pretty much better here. You can just print it, or print your array in a good way. But yeah, that's to keep the video simple. I'm just doing it in this way. So node index.js, and it has got right. I mean, it has not. Okay, so there is some mistake that we're making. Let me see what it is. So if value is greater than current, then what we will do? Current dot write, or if there is a current dot write. Okay, so current dot write equal to new node, and then we will simply assign this to that. Okay, I think this one is right. Okay, so where is the problem? If I'll like, okay, so I'll see you after debugging it. Okay. Okay, so we forgot one thing here. It's like we were checking current. Okay, so instead of doing this, because it's a node, right? So we cannot like compare value with current node. What we can do, like we can like you have to just extract the value of current node, and then you can compare it. So that was the area where we were missing, and yeah, I fixed it, and now it's working. So now let if I print this, here you can see like it has inserted 50 at right place. So that's how you can like build a simple binary search tree in JavaScript. And I hope you got it right. If you haven't, like you can literally uh, if you so basically if you haven't understood this yet, so you can ask me in comment box. I'll try to explain it uh, and give you as much as you know. I'll try to explain as much as I can, but yeah. And there's one more thing which I can suggest you is like I here I've done it with while loop, and for information you can do through recursive sort of thing, recursion and all. Although you can try that by yourself because it's gonna be fun. It will be fun, really. Okay, so yeah, that's it for today's video. I hope you liked it. If you liked it, then don't forget to hit the bell icon and subscribe this channel. I mean, kind of push it. Like first, hit the subscribe button and then hit the like button. Okay. So yeah, I'll see you in the next video. For then, goodbye. See ya.